Hello, 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 hello. I think it is time for us to go here. There we go. What's up, everybody? How's everybody doing? Let's see. Are we firing on all cylinders? That's the question. Do I need to push some buttons here to make stuff happen? I don't know. Maybe. Maybe. All right, what do I got? Let's see. It's a little dim in here, isn't it? Let's get some lights going. Let's get some good mathematical lights happening. So if I push that button, oh yeah. Oh, that is mathematical lighting if I know mathematical lighting. That is it. All right, I'm just checking to make sure that everything that was previously on fire is on fire and that nothing new that was not on fire is now on fire. Hey everybody, welcome. Welcome. It's me, it's Joey. Yeah, let me tell you what I do here. And we're gonna get to it. We're gonna have a good time. We're gonna do a little SAT prep today. So yeah, let me tell you a little bit about myself. So I've been a math teacher for a very long time. I am now a full-time math tutor, and I'm working on creating some content, including PSAT, SAT prep, and so this week is it's just kind of my way to put some of my thoughts out there and help folks that are preparing for the SAT, and also just to do some reflecting myself on what a SAT program could look like if I were to develop one. So yeah, that's why I'm here. That's why this is free. Let's talk. Let me see. Oh, good. This button works. Okay. So, hey, look, it's my website. So I have a website. It is everyonelovesmath.com. But if you go to everybodylovesmath.com, I own that one too. So don't listen. You sound alike websites. Don't come for me. So yeah, this is my website. Everyonelovesmath.com. Listen, there's a couple of real nice things on here. If you're looking for a math tutor, that's me. I can totally be your math tutor. So check this out. There is a button at top that says tutoring. I'm going to click on that. Now check me out, man. This is tutoring. I offer tutoring by the hour or half hour. I also offer tutoring bundles, and those bundles are discounted. We'll talk about that in a second. So watch how easy this is. If I wanted to book an hour, right, I can click on book an hour. It loads up my calendar instantly. So maybe I want to go to Monday the 25th. It shows my available times on Monday the 25th. So why don't we click on 3 o'clock, hit next. You enter in a couple things, right? You enter in your name, your email. You agree to my rescheduling policy, and then you pay. That's it. That's all you have to do. I'll take care of the rest, man. So once you pay, you get a. Let me come back here. So once you pay, you get a automatically generated email from me with the Zoom link and a request for any files or pictures that you would want to send me about the math, and then we go from there. It's I set it up to be what I hope to be a really easy process. All right, so let me also talk about the tutoring bundles. So right now, if I click on my bundles, I offer a 5-session bundle, a 10-session bundle, and a 20-session bundle. And I offer those at 5, 10, and 20% off my hourly rate. All right, so for the month of August only, since we are talking about kind of coming back into things, you can use coupon code Return of the Math. If you use coupon code Return of the Math, you're going to get an extra 10% off in addition to those bundle discounts. I pass the savings on to you. All right. So that's my website. That's everyonelovesmath.com. You love it. You love it. Go there. It's great. All right. So let's get everybody caught up, right? So what happened last night? So last night we got together. That stream is posted. The archive of that stream is posted on YouTube. So we got together last night, and I showed you some stuff about this graphing calculator. And what I figured I would do, and I put it in there. I put it in there as our list of things to do today. Today we're going to talk about quadratics. And we could, I mean, listen, man, give me a Mountain Dew and have me talk about quadratics for an hour. I can do that. But instead of talking about quadratics and just, kind of going over, like, generally some SAT questions on quadratics, I want to show you, kind of like we did last night, how the Desmos calculator, the built-in free graphing calculator on the SAT, can actually help you answer math problems from the SAT with almost like no writing down. And that's coming from me. Listen, man, I'm a math teacher. I'm a show your work kind of dude. But so it pains me to say that I'm going to be encouraging students not to show their work. But listen. You have to figure out your strategy for this SAT. And one of the things that I think about if I was going to be working on my strategy, is I'd want to know as many different ways to approach a problem as possible. I'd want to know if there was a huge time saver on the test, which there is. And the other reason why I don't feel bad showing y'all how to use the calculator to make the SAT simpler is because there's plenty of complicated math on the SAT. So if we have the option of trying, making some math a little less complicated, I'm going to take that option 100%. Okay. So, let's get into it. All right. So let's talk about, here we go. Let's just talk about this week and then we go. So this week we did linear equations in the graphing calculator yesterday. Today we're going to look at quadratics. Tomorrow we're going to look at some geometry problems. And then Thursday we're going to do some word problems. Just kind of catch up on some word problems here and there. So we'll see the extent to which we use the calculator tomorrow on Geometry Day. I'm going to guess that tomorrow is going to be less calculator and more like, hey, let me show you the couple of geometry secrets that are going to unlock that part of the test for you. Okay. So what do we got? What do we got today for our resources? So first thing you need to know is I have several SAT questions. These are released SAT questions from College Board. So that's why I feel okay sharing them with you. This one here happens to not be a quadratic. It's a polynomial, but you'll have to forgive me for that. I wanted to show you a way that the calculator can help you answer questions like this. And then the rest of the problems after the first couple are quadratics. The other thing that I have to help us is Desmos. So if you are taking this test on Saturday and you have not played around with the Desmos calculator yet, here's what you need to do. You need to go Google Desmos, Desmos, Desmos SAT calculator. Desmos is my favorite calculator, and it's free. It's free, and you can use it on every single problem on the SAT. Every single problem. There's no longer a calculator portion and a non-calculator portion. It's all calculator. So you've got this beautiful, wonderful, fast calculator that you can use on every question, and that's exactly what we're going to do together this evening. All right, so just to tell you what I've got my calculator ready to roll. This calculator will be basically the exact same calculator that you're going to see on the SAT. And then what I'm going to do for tonight is I'm going to kind of give myself the same challenge. Let's see how many of these we can answer with just using the calculator and not even like using the pencil. All right, let's see how little we can use the pencil today. Okay, so yeah, and yesterday I feel like I went kind of fast. I'm gonna try to slow down today and just kind of be more. I'm gonna be more chill on YouTube, man. But yeah, let's see where we go. I'm excited. Okay, so if we're gonna do this thing, and we're going to subtract these polynomials. I'm not saying this is the hardest problem on the planet. This is a distributive property and collect like terms problem, but I do want to show you that the graphing calculator, Desmos, can help you in ways that you don't even know. So let me go. I'm just gonna straight up type this expression into Desmos. And unlike with distributive property and combined like terms and all that business, I'm not going to do any of that. Because the thing that I'm worried about and the thing that's nice about Desmos is if I typed in that expression exactly as it is on the SAT, then I know I haven't made like any kind of typo, I haven't made any kind of goofy error or whatever, so I'm feeling okay. All right, so I just typed in that expression and we get this thing. I don't know what you call this thing, but this kind of little squiggle. So how can the Desmos help you when you're trying to just subtract polynomials? Well, what we can do is we're going to graph A, B, C, and D, and we're going to just see which one has the identical squiggle. All right, so check it out. And of course, by identical squiggle, I mean which of these graphs the same as the original expression. So here's A, right? A, I'm going to click and hide it so you can see it pop in and out. So A is a totally different squiggle, right? These are two different expressions, because if they were the same, then they would graph the same. So A we can eliminate as a possibility. All right, let's go to B. So B says 7x to the third power plus 10. Oops, 7x to the third plus 10. So we're going to type it in exactly as it's seen, right? Exactly as we see it, we're going to type it in. And ooh, this one makes me kind of happy. Look at this. If I show and hide this graph, this is like the exact same function on top of itself. Hey, y'all, I'm feeling like B is going to be the right answer. Just to be sure, let's graph C and D, and we're going to show that C and D do not look as pretty as this, where they're like right on top of each other. All right, so let's graph C, right? And we're expecting this to fail. 8x cubed plus 10. Let's see here. 8x cubed plus 10. All right, where is that other graph? Are these really close? Ooh, these are really close, aren't they? All right. Uh-oh, so now we have some competition here between B and C. I might have to, so here's where I might have to like zoom in even more. Are these right on top of each other or what? Oh, ooh, look at this. Look at this. Ooh, zooming in. Zooming in reveals the truth. So what this shows us is that even though, I'm going to hit the home button to go back, even though these kind of look like they might be the same function, if you zoom in super close, like I just did, right? Let me do it again. If you zoom in, let me find you. Ooh, look at that. They are not the same function. They're just really close. All right, so C I can cross out. And then D, you're going to work very similar. So let's make it 7x cubed plus 6. Oh, yeah. That's nowhere near the right answer. All right, so if you take the original expression and graph it, and then graph the multiple choice, only one of them syncs up perfectly. And so in this problem, your answer is B. All right, same idea here. Which expression is equivalent to this subtraction problem? So for this problem, like, let's just put it out there. You probably wouldn't use your calculator to do this, right? If you have 12x cubed, take away 5x cubed, that would be 7x cubed. 12 minus 5 is 7. But the way that we just did this in Desmos, you could do the exact same thing here. Graph the original expression, graph the multiple choice, and see which ones line up. Okay, same kind of problem here, right? What I did was I found all these problems on the SAT. Here's another one. This is a polynomial subtraction problem. But no worry about it being a polynomial subtraction problem. Once again, if you put the original expression in Desmos and put the multiple choice in Desmos, see which ones have the squiggles overlap, right? Which ones graph to make exactly the same graph. You're going to be able to do these problems like without a pencil, which is kind of insane. Okay, so let's move on to a different type of problem. So this one, like the ones we were doing yesterday, this one says, what is the sum of the solutions to the given equation? Okay, so let's break that down for a second. First of all, they're saying solutions. That must mean there's more than one solution here. And looking at this equation, you might be able to tell why, like x times x, if we were to distribute that x out, this would be an x squared. This is a quadratic. And we know that quadratics, most of them, like your average quadratic, has two solutions. Okay, so what they want us to do here is they want us to find the solutions, and then, and I'm going to make myself a little note, they want us to add up those solutions, right? Because they're asking us for the sum of the solutions. Okay, so as far as finding the solutions to a quadratic, you've got some options, right? You could do quadratic formula. You could try to factor it. You could do completing the square. You could try to do reverse operations. You could try to do it in your head. But the other method that I want to make sure that you know that a lot of teachers don't teach is we could do this by graphing. And so the easiest way to do this by graphing, so here's what I could say. There's kind of two ways to do this. One way, we could just type this equation into Desmos and see if it shows us an answer. Let's do that. Let's start with that. So we're going to do x times x plus 1 minus 56 equals 4x times x minus 7. Oh, look at that. It did give us some answers. So let me look at this extra carefully here. Oh, I didn't want to hide that. I wanted to show all of it here. So I typed in that equation exactly, right? And if I look here, it gives me two answers, but when sometimes when Desmos finds the answers, it's not very good at giving them to you. So like for here, this one, it looks like 7 is maybe the answer, but this point over here, that point looks like maybe a fraction. All right, so sometimes putting the equation in is helpful, and sometimes it's not. So let me show you, I'm going to reset my graph. Let me show you what to do when you type in the equation and it's not clear. So the other thing we're going to do is we're going to graph both sides of this equation as separate graphs. So we're going to do a y equals the left side. We're going to do a y equals the right side. And then we're going to look and see literally where do the left side and the right side match up. All right, so let me show you what that looks like. So I'm now typing in the left side y equals x times x plus 1 minus 56. All right, so there, and I can zoom out to see it, right? So that is the graph of the left side of this equation. On the second line, let me graph the right side of this equation, 4x times x minus 7. All right, there we go. So if we're going to solve this by graphing, then what we need to do is we need to find out where these functions intersect. And specifically, think about the equation as it's written here. We need to see the x values where these two functions intersect. All right, so lucky for us, Desmos should let us click on stuff here. Let's see. Is it gonna let me click on business? Ooh, Desmos is Desmos. There we go. What? Ooh, okay. I might have to refresh my business here. Sometimes Desmos likes me. Sometimes Desmos doesn't like me. So let me type that back in. It's all right. Your Desmos on the SAT will be reliable. The only reason why mine isn't reliable is I've got it going through a couple different things on my end just to make everything work. Okay, so here we are again. All right, and I'm gonna zoom back out. Oh boy, let's keep zooming. Oh yeah, Desmos, you're going weird with me today. All right, so I'm gonna continue to zoom out. And will Desmos allow me? Ooh, it's being moody today. Ooh, okay. So what I'm gonna need to do, gotta call an audible here. What I'm gonna need to do is I'm gonna need to take Desmos. My button broke. So I gotta grab a fresh Desmos. Stand by. Let's do it. So I'm gonna open up Desmos.com and go to my calculator. There we go. We'll just do this the good old-fashioned way. All right, so for the left side, we're gonna do y equals x times x plus 1, and then minus 56. And once again, there is our quadratic that by now we're used to seeing, right? We're used to seeing that thing. Okay, now I'm going to type in the other side of this equation, which was y equals, it was 4x, then wasn't it x minus 7, right? 4x times x minus 7. There we go. Okay, so now we've got that typed in, right? There we are. And now I can zoom out. Desmos is going to work with me a little bit more here. And now we can look and find the intersection of these two graphs. Because wherever these two graphs intersect, it must be where the left side and the right side are equal. Okay, so check this out. One of the points is where x is 2.666667. All right, so if you know your thing, you know that is 2.666667. That's like 2 2/3, right? So I'm going to write 2 2/3. That's one of the solutions to this equation because it's one place where the graphs connect. All right, the other place where the graphs connect sure looks like it's somewhere around here. Is it right there at 7, 0? I think it is, right? Yep, those graphs intersect at 7, 0. And so when I go to do my work over here, what we need the sum of these two numbers, 2 2/3 and 7. So that's 9 2/3 if we just add them as mixed numbers. But that's not going to work for the SAT. The SAT will not tolerate mixed numbers. So how about we convert this? 3 times 9 is 27, plus 2 is 29 thirds. So this problem, you would want to type in that. There's a couple ways to type your answer, but the most straightforward one, type in 29 thirds, because the SAT does not like mixed numbers. It likes improper fractions. Okay, cool. So next one, what is a solution to the given equation? So with this one, we're going to adopt the exact same plan. We're going to put y equals the left side into the calculator. We're going to do y equals the right side into the calculator. The only thing we're going to need to change in order to make Desmos graph this is instead of the variable d, we're going to use the variable x. If we use the variable x, then Desmos will know, hey, graph the left side, graph the right side. Let's look and see where they intersect. Okay, so here we go. I've got my deal here. We're going to do y equals, and we're going to graph the left side. So x minus 30 times x plus 30 minus 7. All right, so let's take a look at this thing. I think this is, let's see, where am I? Did I do, oh, there it is. Oh my goodness, that's a big old parabola, right? That is a big old parabola. All right, and now we're gonna graph the right side of this equation. And the right side of this equation is just -7. So we're gonna type in y equals -7. All right, So if we look at this, y equals -7 is a horizontal line, which it absolutely should be. We want to know where the green, so the green graph represents the left side of the equation. The purple graph represents the right side of the equation. And Desmos knows that we love us some intersections. And so in this problem, let's see, the two places where these graphs intersect are 30 and -30. And so in this problem, they ask what is a solution to the given equation. So if they want a solution, we can just type in 30, right? We could also type in -30, but whatever, we want to make sure that we answer the instructions that were given to us in the problem. Okay, I think you're going to see where this one is going, right? This one says, what is the positive solution to the given equation? So now they're telling us which of the probably two solutions they want. We're going to do this by graphing. We're also, once again, going to change the k to an x. And let's see what it looks like, okay? So when we graph this, we're going to do y equals the left side. So I'm going to write y equals x squared minus 53. And then I'm going to do y equals the right side. So y equals 91. Okay. And it says, what is the positive solution? Oh, look at us. I'm already pretty zoomed out, right? So the negative solution is right here. This must be the positive solution. The positive solution is where x equals 12 and y equals 91. So they want to know what is the positive solution. Well, this was an equation with x in it. So they want to know what is x? X is 12. All right, and now once again, just like last night, you can notice we're doing this. We're answering these SAT questions without needing to do virtually any work on our paper. All right, there'll come a time for that. There'll come a time, but it ain't right now. Here we go, 14. What is one of the solutions to the given equation? Okay, so once again, we're going to graph the left side. We're going to make sure that instead of z's, we put x's, right? So we'll make it x squared plus 10x minus 24. But let's graph the left side, let's graph the right side, and let's see where they hook up. So here we go. I'm going to delete the old stuff. And now let's put in y equals x squared plus 10x minus 24. All right, so that's a quadratic, right? And then on the right side, we put in y equals 0. And y equals 0 is just the x-axis, right? I can zoom back in on this. Where are we going? Right here, right? So y equals 0 is that green line. It's just the x-axis. All right, so in this problem, what do they say? What is one of the solutions? Well, there are two places where these two functions intersect. There are two places where the left side, the blue side of the equation, and the green side are the same. Those happen, and look right on your graph. Those happen when x is -12 or when x is +2. All right, well, going back to the SAT, once again, they just want one of them. So why don't we just type in the positive one, because there's less of a chance that I'll mess that up, right? So 2 is one of the solutions. Do y'all see a pattern here? Do y'all see what being studied for the SAT really means? It doesn't mean working really, really, really hard. That's not what being prepared for the SAT means. What being prepared for the SAT means is by the time you get there, you don't have to work hard because you've done the work to prepare. Okay, now technically this one is not a quadratic, but I wanted just to see if we could solve it anyway. This one says, what is the positive solution to the given equation? Let's do that thing where we just do y equals the left side and y equals the right side, and let's see if Desmos can handle this. Oh, look at that. 55 over x plus 6, Desmos graphed that, and then we'll do y equals x. Right, so I did y equals the left side, I did y equals the right side, and now let's see where we're at. All right, this is kind of a cool graph, right? I can zoom out so we can see more of this. So once again, let's see, the purple side represents the left side of the equation. The black side, or the black line, represents the right side of the equation. And remember, they asked us for the positive answer. So that's going to happen over here. Look at that. The positive answer happens when x equals 5. And so once again, with very little work, right? No scratch work. And it kills me to say no scratch work. We can get the answer to that problem. Pretty good, man. Pretty good. Okay, here we go. Which ordered pair, x comma y, is a solution to the given system of equations? So this is another one where you don't have to graph this, right? None of these you have to graph. But I want you to understand that if you choose to graph it, it might answer the problem for you. So let's see what they do here. I'm going to type x plus 7 equals 10, and then I'm going to do parentheses, x plus 7 squared equals y. All right, so I'm just typing both of those functions in. So we have the red function and the blue function, and we want to know, once again, which ordered pair is a solution to the system of equations. So where does this red line and this blue curve intersect? How about right there? Right, and I can zoom in to see it. It sure, yeah, look at that, man. Dude, that makes it obvious. 3 comma 100 is the intersection of those two functions. It's the intersection of the left side of the equation and the right side of the equation. It's the solution to the system of equations. So your correct answer choice here is A. All right. Another system. And this one, they get tricky on us. So check it out. It says in the given system of equations, A is a constant. The graphs of the equations in the given system intersect at exactly 1 point. What is the value of x? So they want to know what is the x value of the intersection of these two functions. Okay. Time to graph these two functions. Y equals 2x squared minus 21x plus 64. So there's our first function, big old parabola. And then for our second function, we'll do y equals 3x plus a. And now here's the wild thing. Desmos knows that it knows that it doesn't know what a is. So we can say add a slider for a, and I'm going to show you what that does. So let me go back. Let me move my calendar out of the way. Let me go back to normal, and I'm going to zoom out from there. All right, so check this out. We've got the purple graph and the green graph, right? These are the two functions. So now I can see them clearly, right? I've zoomed out so I can see it. And notice that a being a constant and generating a slider, I can actually slide a up and down. And listen, y'all, I can do this on the test, okay? Now, according to the instructions, they want the purple line and the green parabola to intersect at exactly 1 point. And so all I have to do is adjust myself here. I think this needs to be like down here somewhere, right? So that they intersect at exactly 1 point. So I just put it, a is -8. Let me see. Let's look. Ooh, this is looking real good. Does this intersect at 1 point? Oh, look at this. Well, let me click on it. It should if they intersect. Where is it? Oh boy, is it right here at 6? It's got to be something like right there at 6. 6 comma 10. Right? And I'm squeezing in right there to see it. 6 comma 10. That feels like that might be the intersection. All right, so what could we do? We could plug 6 in for x in both of those functions to double check. But sure enough, these two do intersect at the point 6 comma 10. And so it says, let's look at the question. It's asking us what is the value of x? Well, if they intersect at the point 6 comma 10, then the value of x is 6. Love it. Love it. You love it. All right. Let's go. Let's go. Let's use Desmos to answer these. And these are known to be the tougher ones. All right, so this question, if you were going to answer this like for real, you would want to know about the discriminant of a quadratic, right? The discriminant of a quadratic will tell you about the nature of the solutions. However, if we don't have that information, we can go and graph, once again, graph both sides. So let's graph y equals the left side, 5x squared plus 10x plus 16. And then we'll do y equals the right side, which is 0. Okay, and then let me go, let's see here, head back up here, and we'll hit the home button. All right, so y equal, oh, look at this. Oh boy. So remember, it's asking us how many solutions does this function have? So it's asking us how many times, and I can zoom out some more, how many times will this red parabola intersect this horizontal line? I think we all know the answer to that question. It doesn't. So just by graphing, once again, the left side and the right side, and by being a little observant, we know that these two, that the left side and the right side will actually never equal. So this equation would have 0 solutions. Okay, let's see. Here's another one. A solution to the given system is x comma y, where x is greater than 0. Okay, so we want to just double check that we're looking on the positive side of the x's. But it looks to me like we're going to do this one like we've been doing. Let's graph both of these equations, and let's look for where they intersect. So we're going to graph y equals 4x, and we're going to graph y equals x squared minus 12. All right, so we graphed both of those. We want to make sure we pick a spot where x is positive. Oh, I already see it. Do y'all? It's right here. Look at that. This right here is a spot where the two equations intersect and the x is positive. So I think they're asking me about the point 6 comma 24. And so the value of x would be 6. All right, think about this pattern again. We have done a lot of work today. We have answered a lot of SAT questions. And we've done it with like barely even picking up our pencil, right? We've done it just by being observant and knowing the power of our calculator. I mean, that's really where it's at. Okay, let's see. Let's see what's next. So I think I have a couple more. All right, so let's look at this one. Which of the following is a solution to the given equation? And this one, oh, look at that. All the answers are ugly, right? So we know these are all ugly. But we also have a plan. We have a procedure for finding the solution to any quadratic. What are we going to do? We're going to swap out those w's for x's, and we're going to graph it. So we're going to graph y equals the left side. So that's x squared plus 12x minus 40. Right? There's our parabola. And then we're going to graph the right side, y equals 0. And y equals 0 is going to be that horizontal line right at y equals 0. Okay, so now we want to know, where do these intersect? And they intersect in kind of gross places, right? Look at those numbers. 2.7178, that's got to be rounded, right? And then negative 14.7178. So you might be thinking to yourself, I don't know if I can use Desmos to answer this question. And I'm going to tell you, yes, we can. All right. And here's what we're going to do. These answer choices are all ugly, right? And so what we're going to do is we're going to type these answer choices into Desmos and see which ones give us one of these numbers. One of them will, right? So let me show you what I mean. The first one is 6 minus 2 square root. Let's see, you could type in SQRT for square root, or you can just click the functions button. 6 minus 2 root 19, right? So this is choice A. Does this look like one of the answers? Well, this one was negative 14 something, right? And this one over here is positive 2.7. So that tells me A cannot be the right answer, right? It doesn't equal. So I'm going to cross that one out, and we're going to try B. Let's try 2 times the square root of 19. Well, all right, 2 times the square root of 19, that's 8 point something, which is neither of those points, right? Remember, it was like negative 14 something and positive 2 something. So we now know the answer can't be B. All right, let's try C. So C is just the square root of 19. Nah, neither of those numbers was 4.35. So now we try the very last one. How about negative 6 plus 2 Square root of 19. Okay. Positive 2.717. And this is positive 2.7178 rounded. Yeah. Yeah. For this problem, D is the right answer. All right. And again, like, this is not an easy problem. What they would have expected us to do to get that answer without using the calculator, we would have had to have either used the quadratic formula or complete the square. Those are the two ways that you could have found the answer. So graphing avoids the entire thing altogether. It's awesome. Okay, you can probably see where this one's going, right? What is the positive solution to the given equation? Well, let's graph the left side. Let's graph the right side. And let's see where they match up. All right, so I'm going to go here, and I'm going to type in y equals negative 4x squared minus 7x. Okay, there's our, I'll zoom back in, there's our frowny face quadratic because it's a negative x squared. All right, and now we're going to do the right side of the equation. Y equals negative 36. Okay, so what do we want? The positive solution. Well, negative 36 is going to be way below the x-axis. So you might wonder, what do they mean by positive solution? Remember, this is an equation with x's in it. So they want the one where the x is positive. That's right there. Right? There's two solutions here where the x is negative at negative 4. We're not going to look at that. And then where x is 2.25. So all you have to ask yourself is which one of these lines up with 2.25? And if you're still not sure, you can always put 7 divided by 4 in the calculator. That's 1.75. If we do, if we do 9 divided by 4, that's 2.25. So again, at every step of the way, I'm using Desmos just to like make it so that I'm not having to run my brain overtime to get these right. Okay? Looking good, looking good. Okay. I think we're going to make this the last question. I think this was the last one on my list for tonight. So this one is another quadratic. And this one says one solution to the given equation can be written as 1 plus the square root of k. What is the value of k? So once again, this would have been a quadratic formula or a complete the square. I can tell you, you would have had to do some simplifying and stuff. Not with me, man. Not with me. We can go straight to Desmos. So let's do this. Let's graph y equals the left side, y equals the right side, and let's look and see where they intersect, okay? So we get